Welcome back. This is an Aleks homework video on writing the dissociation reactions of a polyprotic acid. So protic comes from the word proton, and when you put an acid in water, it dissociates. What that means is it breaks into normally a hydrogen ion, which is a positive, and then whatever that hydrogen was attached to, that's the remainder, and it will be negative. Now, acids usually are made up of nonmetals, which are covalently bonded. So this is not an ionic bond. It's not like a salt that when a salt is put in water will break apart into the ions that it started as. These are covalently bonded, sharing electrons, but when an acid goes into water, it does break apart as ions. So in some ways you can kind of think of it in an ionic way. This is not very hard when you have a normal monoprotic acid, so one proton, so HCl, or anything that usually starts with the letter H. Okay, you have an H for hydrogen, and then whatever it's attached to will break apart as a proton, and then leave whatever's left as a negative ion. And then that proton joins to water. So you've put it in water, and it joins to water. Well, that H plus will join with water to make a hydronium ion, which is H3O plus. Okay, so let's look at the first one. So this is a polyprotic acid. You've got more than one hydrogen that it's going to donate. So when I write the first one down, I have sulfuric acid, which is H2SO4. It's going to donate one proton in the first step. So this mechanism is going to be considered to happen in two steps. It'll give out a proton, and so it gives it to the water. You put it in the water liquid here, and makes a hydronium, H3O plus. Now, Aleks needs all this to be in aqueous and liquid, so be sure to do that to get it right. And then whatever the hydrogen was attached to becomes, at the end, with one less hydrogen and one less positive charge, so it will become negative. It will become more negative each time you reduce a hydrogen. So since it was neutral to start with, H2SO4, when one hydrogen is donated to the water to make hydronium, what's left over in this first step is HSO4, because I've reduced it by one, and made it more negative. Since it was already neutral, in order to make it more negative, I had to make it negative. So it's -1 here. HSO4, -1, and it's aqueous. Now the HSO4, -1, has a hydrogen to give, so it is also an acid. This bisulfate ion is an acid. So when you put it in water, now it's already in water, it's just going to happen as a second step, and it will donate its proton to the water, making hydronium, and then you reduce it by one hydrogen and reduce its charge again. So when the hydrogen's gone, you'll end up with just sulfate ion, SO4, -2. So hope that helps you to see it written out. You may be able to do this one, I think.